Hi everybody. I wanted to take a couple minutes here to kind of give you some information about using substitution to solve a system of equations. And we've done a little bit of work with this already last semester when we did our cars and we set the math models equal to each other. That's technically a form of substitution. What I want to do today is show you a way to kind of generalize that so we can use it with really any two equations where you have two variables. And in this case, we have two equations on the screen with two variables. Before I explain how to do the problem, I want you to pause the video, and I want you to take a moment to write down the 4 steps that are listed on the left-hand side of this screen. So go ahead and pause the video now and press resume when you're done. All right, now that you've had a moment to copy down the steps, what we want to look at is applying those steps to a specific example. And so the example that I have here has two equations. What we want to do is take one of those and solve it for either x or y. And so as I look through both equations, one of the things that I notice on this top equation here, I notice that the y has an understood coefficient of 1, and that generally is the variable that you want to get by itself. So I'm going to circle this y and realize that I'm going to isolate that term. So I'm going to take that equation off to the side. 5x plus y equals 12. And to isolate this term, I'm going to subtract 5x from each side. Similarly to how we did this when we solved for slope-intercept form. So now the 5x cancels out. We're left with y is equal to 12 minus 5x. You can also rewrite that in slope-intercept form if you want. Negative 5x plus 12. Either way is fine. I like to kind of get it in a format I'm familiar with, so I'm going to use this math model here. All right, now, I worked with equation 1 already. At this point, what we want to do, if you look at step 2, it says we're going to substitute y or x into the other equation. And so since I solved for y, wherever I see a y in the second equation, change my colors here, I'm going to take whatever I got y to equal, I'm going to take this expression and plug it in right here instead of writing the y. All right, so equation 2 is now going to look like this. We're going to have 2x minus 3 times something equals negative 2. And instead of writing y here, we are going to replace it with whatever we got on equation 1. So we said over here, y is the same or equivalent to negative 5x plus 12. So I'm going to put negative 5x plus 12 right here instead of writing my y. And now we have one equation that only has x's in it, and it doesn't have both x's and y's. All right, and so if we follow PEMDAS on the left-hand side, we have to distribute this negative 3 to the parentheses. So I'm going to copy my 2x, and we're going to take negative 3 times negative 5x, which is 15x. And then we're going to take negative 3 times 12, which is negative 36, and set that equal to the right-hand side, which is negative 2. All right, now, this is where I see a lot of mistakes happen in this class. 2x and 5x are like terms, and they're on the same side of the equal sign. So we don't use inverse operations. We just combine those to say 17x minus 36 equals negative 2. All right, and if we add 36 to both sides, now we can do PEMDAS backwards because we have we have simplified the left-hand side as much as we can. Okay, and so let me just zoom out here. Let me see if I can pan the screen a little bit. We're going to move that all up so we have more room to write. And let me get my pen tool. Okay, so we'll end up with 17x equals 34, which means if we divide by 17, x is 2. All right, now the solution has to have both an x and a y. So the x coordinate is 2. We don't know the y value yet, but we can easily figure that out. by taking my equation up here, this one, and every time we see an x, we can replace it with 2. So I'm going to say y equals -5 times 2 plus 12. So y equals a -10 plus 12, which means y has to equal 2. So my solution would be the ordered pair 2, 2. And I'm going to check to make sure that's accurate by going up to my math models and just substituting those numbers in to see if they actually do give us a true statement. So all I'm going to do is every time I see an x, I'm going to replace it with 2. And every time I see a y, I'm going to replace it with 2 as well. So if we check this out, I'm going to put a 2 in for x and a 2 in for y. 5 times 2 is 10, plus 2, oops, that was supposed to equal 12. I copied it down wrong, equals 12. Is that a true statement? Yes, it is. So we know that one checked out well. If these aren't true statements, when we plug the numbers back in, we made a mistake. Okay, let's try the same thing on the next equation. So 2 times x, which we got an answer of 2, minus 3 times whatever we got for y, which was 2. That's supposed to equal a -2. All right, let's see if that actually is true. 2 times 2 is 4. A -3 times 2 is -6, would be -6 equals -2. Yep, that's definitely a true statement. So that makes me feel very, very confident that the ordered pair to the solution is 2, 2. All right. Write down at this point what questions you have, and we'll go from there. Now that you've watched the first part of the video, I want you to answer these 2 questions on your handout independently, please. It doesn't really matter at this point if you get them right or wrong. I want to use this to see how much we understand the content that you just learned. So please pause the video and answer those questions. Okay, now that you've answered the last 2 questions, we're going to do another example that's a little bit different than the last one in the sense that if you look at each of your variables on the screen, all of them have a number or a coefficient in front of them. So we're just going to pick one equation. It doesn't really matter which one. So I'm just going to number, oh, come on, give me my pen. There we go. Got the wrong color. All right, I'm going to call the first one equation 1 and the second one equation 2. So I'm going to just take equation 1. I'm going to say solve equation 1 for, and we can choose x or y. I'll go x this time since we did y last time. So we're going to take a -3x minus 3y equals 3. And we want to get this term by itself and then eventually the x by itself. So I'm going to do PEMDAS backwards. Since I don't have any like terms I can combine, I'm going to add 3y to both sides. My pen's being kind of ornery right now. There we go. Oh, no, darn it. All right, let's see if we can get this to work now. 3y, sorry about the technical difficulties. So I have a -3x equals 3 plus 3y. I'm going to divide everything by a -3 and simplify. So I get x equals a -1, and then 3y divided by -3 would be a -1y. All right, so now we have x by itself. So if you look at your steps, first thing we said was solve for y or x, and we did that. We got x by itself. So now we're going to take my second equation, and every time I see an x right here, I'm going to replace x with what you see in the box. All right, so let's just take equation 2, and we're basically trying to get it so we only see one variable and not two. So I'm going to write 10, instead of writing x, leave a big parentheses, and then plus 2y equals negative 34. Again, just copy the equation, but don't write the variable that you're going to replace. All right, so now where the big space is, we can insert this expression right here. So we're going to put negative 1 minus 1y, and now we just do PEMDAS on the left side to simplify. So I'm going to distribute first. So we'd get a negative 10 minus 10y plus 2y equals negative 34. All right, I see two like terms. Make sure you include their signs. They're on the same side of the equation, so I'm just going to combine those to get a negative 8y equals negative 34. And if I add 10 to both sides, we get negative 8y equals negative 24, which means, I'm just going to draw an arrow coming up here, which means y is equal to 3. Okay, so to get our next answer, let's take, and I'll highlight this so you can see, we're going to take what our math model is to get x. We're going to replace the y with the answer we just got. Okay, so like if you think about the solution, we know the y value is 3 right now. We don't know what x is. So my math model for x says you can take negative 1 minus 1y. So I'm going to say negative 1 minus 1 times 3. So negative 1, and then negative 1 times 3 is negative 3. So x has to be negative 4, which means our solution, when we graph this, would occur at negative 4, 3. That'd be the same thing as writing your answer as x equals negative 4, y equals 3, but this is the shorter, more concise, and more mathematically correct way to express your answer.